Go for main engine start. We have main engine start. 2, 1. Booster ignition and the final liftoff of Discovery. The shuttle has cleared the tower.
The production of this film has been made possible by a generous funding from Badur Charitable Foundation.
They have been en ride into orbit. Discovery now making one last reach for the stars, reducing the stress on the shuttle as it goes supersonic.
Discovery Houston, you are go at throttle up.
Discovery's engines are now throttling down as the orbiter passes through the area of maximum pressure. Commander Steve Lindsay acknowledging the call from Capcom Charlie Hobaugh as Discovery's 3 main engines throttle back up.
T-minus 16 seconds. Sound suppression water system has been activated. Pad from protecting Discovery and the launch. We have a go for main engine start. T-minus 5, 4, 3, 2, 1. Booster ignition and liftoff of Discovery, hoisting harmony to the heavens and opening new gateways for international science. Discovery has cleared the tower.
Liftoff, liftoff, indeed. To some people, this is truly the moment of illumination in the story of modern science. A full-rounded, four-dimensional moment that triggered into an almost totally new dimension man's age-old quest for answers to a few existential questions. Where did we come from? How did this happen? And what is our destiny? Questions among many that persistently preoccupied our human race since time immemorial. Ancient myths, created by that quest, were the outcome of many a civilization. Philosophers and early scientists, driven by human curiosity centuries ago, have had their fair share of search and research. When darkness reigned, even before the advent of the Middle Ages, those mind expeditions were destined to gain new ground. For a few centuries, a remarkable contribution was made to the birth of modern age. But when the torch was about to die out, a few courageous men had ultimately managed, against all odds, to pick up the torch, and eventually the pursuit for scientific answers acquired a new momentum. And over the last 100 years, man's quantum leap into almost all realms of knowledge has caused a close encounter to happen for the first time on another world.
Okay, engine stop. We copy you down, Eagle. Tranquility Base here. The Eagle has landed. One small step for man, one giant leap for mankind.
Since that defining moment, mankind is still pushing the cosmic envelope into brave new dimensions of science, discovery, and imagination. A free leap into space in an artist's impression seems almost the only gateway to the heavens, a driving force behind man's burning desire to fly out and away, to see and know his place in the universe. He is there now, overtaken by awe and wonder, trying to ascend through what seemed for long forbidding frontiers around those cosmic gates, the gates of heaven. If we were to open for them a gate into heaven, and they proceeded to ascend through it, they would say, "Our eyes have been bedazzled. Rather, we are a bewitched people." 15:15. To the three physicists who garnered, on October 4, 2011, the Nobel Prize in Physics for the 2011 chapter, the fruit of so many years of cosmic observation has finally paid off. Cosmologists Saul Perlmutter, Adam Rees, and Brian Schmidt have been working in teams of astronomers observing the redshift and the brightness of 58 supernovae. They have found that the remnants of nearly all type 1a supernovae are at least 15% further away than what the standard model of the universe predicts. This implies that the universe is open and will expand forever. It also suggests that a bizarre quantum force is affecting the expansion rate. This information was published in 1998. An outstanding discovery that harks back some 70 years earlier, one man's feat some would call the most singular achievement of modern physics. A man called Edwin Hubble had looked into one night sky in 1929 with his telescope and noticed an extraordinary thing. A remarkable observation that would precipitate the revolutionary idea that Professor Hoyle would eventually sneeringly label the Big Bang. What Hubble saw from his mountaintop in California was that the steady, old, dependable universe was in fact anything but steady. Galaxies, he noted, were hurtling away from each other at alarming speeds. Science writer Bill Bryson explains in his 2003 book, A Short History of Nearly Everything, that Hubble had determined that the speed and distance of this retreat are neatly proportional. The farther away the galaxy, the faster it is moving. Hubble realized that this could be expressed with a simple equation, HO equal V divided by D, where HO is the constant, V is the recessional velocity of a flying galaxy, and D is its distance away from us. HO has been known ever since as the Hubble constant, Hubble's law.
In Surah 51, verse 47, Qur'an clearly talks about God expanding the universe with his power. And that to me was very clearly a reference to what we know now about the way the universe is expanding almost at the speed of light in all directions, and something that was only discovered in the last 100 years.
Now behold the heaven, it is we alone who built it with mighty hands, and indeed it is we alone who are expanding it. 47:51. Imagine a vast universe, incredibly cold and constantly expanding. How did it all begin? Let's go back in time. Imagine you're at the very beginning of the universe, nearly 14,000 million years ago. Imagine the energy of the entire universe compressed into a space smaller than a pinhead. Imagine you're inside that tiny space. Time stands still. Nothing we know or can imagine exists. Everything is about to change forever. At this moment, the Big Bang's pure energy is released. In a furnace of heat, space expands at an incredible speed. In the tiniest fraction of a second, our universe is born. This is the deepest of all mysteries. Some of the energy now condensed is antimatter. At this moment, all the particles that make up our universe are created. Some we don't understand yet. Among the others are incredibly small quarks, electrons, neutrinos, particles that will make everything we know, including you. Look closely. They come into being as pairs. Particles and their opposite antiparticles are fatally attracted. They annihilate each other. But some of the matter survive, fortunately for us. Matter that makes up everything we know. As the universe cools, quarks are grouping into three to form neutrons and protons. These make up the simplest nuclei. All of this happens in the first 3 minutes from the beginning of time. But for the coming thousands of years, the intense heat and energy stop electrons from combining with these nuclei. Let's travel on, 380,000 years from the Big Bang. The universe has expanded, and it is colder. Now the electrons are free to surround tiny protons and form the first simple atoms, hydrogen and helium. And as the atoms form, light particles now travel through space unimpeded. What was once a fog of colliding particles suddenly clears. Let there be light. This first light can still be seen as the cosmic microwave background, a permanent fingerprint on our universe. We travel forward for hundreds of millions of years. Now the force of gravity is making clouds of hydrogen and helium atoms contract, triggering nuclear reactions everywhere. The first beautiful stars are born. Some of them are massive. They exhaust their fuel, collapsing on themselves, and, in the silence of the space, explode as giant supernovae. But out of the crucible of destruction come heavy elements, among them carbon, nitrogen, oxygen, iron, even gold, elements that will form planets and the seeds of life. Generations of stars live and die. Formerly intense and incredibly hot, our universe is now cold and empty. After 9,000 million years, in a spiral arm of a distant galaxy, something important is forming. Here, in this infinite space, among millions of galaxies, there is a solar system. In this solar system, one of the planets is cooled enough to allow liquid water to form, and for life to begin. It is our home, planet Earth. And on that Earth are creatures with extraordinary ability to reflect back on the meaning of the universe.
So this kind of building of the universe with an organized structure seemed to sing through to me from that verse, that there was, once again, this is the Qur'an speaking to us, and God is saying, this is divine revelation.
The story of finding out that the universe is expanding has unintentionally started with the cosmological constant idea. In an article published in the New York Times in January 2011 entitled Darkness at the Edge of the Universe, physicist Brian Greene comments on the recent discoveries of the accelerated cosmic expansion and explains a bit more. He says, across large distances, the force that shapes the cosmos is the attractive pull of gravity. And so Einstein reasoned a counterbalancing force would need to provide a repulsive push. But what force could that be? Remarkably, he found that idea that would have, blown Newton's mind anti-gravity, a gravitational force that pushes instead of pulls. Ordinary matter like the Earth or Sun can generate only attractive gravity. But the math revealed that a more exotic source, an energy that uniformly fills space only invisibly, would generate gravity's repulsive version. Einstein called this space-filling energy the cosmological constant. A dozen years later, however, Einstein ruled the day he introduced the cosmological constant. In 1929, the American astronomer Edwin Hubble discovered that distant galaxies are all rushing away from us. Hubble's observations thus established that there was no need for a cosmological constant. The universe is not static. Green reflects on a candid moment of regret. Had Einstein only trusted the original mathematics of general relativity, he would have made one of the most spectacular predictions of all time: that the universe is expanding more than a decade before it was discovered. According to one of his trusted colleagues, he called this mistake the greatest blunder of my life. Green concludes when Einstein introduced the cosmological constant, he envisioned its value being finely adjusted to exactly balance ordinary attractive gravity. But for other values, the cosmological constant's repulsive gravity can beat out attractive gravity and yield the observed accelerated spatial expansion spot on. Were Einstein still with us, his discovery that repulsive gravity lies within nature's repertoire would have likely garnered him another Nobel Prize. However, the cosmological constant remained a subject of theoretical and empirical interest. Empirically, the onslaught of cosmological data in the past decade strongly suggests that our expanding universe has a positive cosmological constant. But how do cosmologists measure an expanding universe? It was physicist Christian Doppler of Prague who first pointed out 150 years ago that a change of a sound pitch would be expected whenever a steady source of waves moved with respect to an observer. Today we call it the Doppler shift. The Doppler effect could be simply observed in the water flow around a swan. Water waves expand as the swan keeps swimming. It turned out that the Doppler shift also applies to light. The light waves of an object hurtling away through space will stretch into longer wavelengths, or red shifts. Nearer wavelengths are blue shifts. By measuring changes in wavelengths of light emitted by galaxies, Hubble realized that galaxies were flying away from each other, and receding galaxies could mean one thing: the universe is expanding. Hubble has greatly contributed to astronomers' knowledge of dark energy and how this mysterious, little understood phenomenon is speeding up the very same expansion of the universe discovered by Edwin Hubble decades before.
What everybody believed was that the universal expansion was slowing down due to gravity. I mean, it made sense. There are no there's no anti-gravity that we know of, but there is now.
An expanding universe means that tomorrow it'll be bigger than what it is today. It also means, of course, that yesterday it would have been smaller, the day before smaller still. And if you keep winding the clock back in time, it eventually arrives at a moment in history when all the stuff of the universe is clumped together in a single tiny region. So, it appeared that the Big Bang believers are winning after all over the steady state clan who appear to have lost their case for good. In the 1990s, there were two teams of astronomers undertaking painstakingly precise observations of distant supernovae. Exploding stars so brilliant they can be seen clear across the cosmos, to determine how the expansion rate of space has changed over the history of the universe. The astronomers concluded that something in space must be pushing galaxies apart ever more quickly, and after scrutinizing the situation, they have found that the push is most likely the repulsive gravity produced by a cosmological constant. In addition to the first group of the Nobel laureates, another group of astronomers, led by Tim Schrabbach of the Leiden Observatory, conducted an intensive study of over 446,000 galaxies within the Cosmos Survey field. The result of the largest survey ever conducted with Hubble telescope, showing independent confirmation that the expansion of the universe is accelerated by an additional, mysterious component named dark energy. That is, the bizarre quantum force the first group has predicted. Once more, using NASA's Hubble Space Telescope, a team of researchers led by Adam Rees found that dark energy was already accelerating the expansion of the universe at least as long as 9 billion years ago. One more proof of the atom being the key to the cosmos. The University of Washington physicists suggested that the accelerated expansion is caused by the discovery of a linkage they say could be caused by a previously unrecognized subatomic particle they call the acceleron with the dark energy. On his webpage at the University of California in Berkeley's website, physicist Pearl Muter tells us one interesting notion. Our supernovae observations were originally performed to measure the ratio of a receding cosmic expansion affected by the gravitational attractive pull. Instead, we have only shown its accelerating expansion.
You check each step of the process, and little by little, you get to the point where you start realizing, this effect isn't going away. This is the right answer. It really looks like the universe is actually speeding up.
Richard Varley seems to be impressed by the scientific significance of many verses in the Qur'an, including the expansion of the universe as indicated in verse 47, chapter 51. Now behold the heaven. It is we alone who built it with mighty hands, and indeed it is we alone who are expanding it. 47:51.
The same voice is saying, look what I have done. I have done this. This is a proof that these words are true. So that's the way I've approached it. And sometimes the science is wrong, and it really is, because we're in an age now when the science is subject to very, very rigorous proof. When the verses concur with the science concurs with the Qur'an, we need to be able to say, as Muslims, be confident and celebrate that and say, look, our book says this, and you just discovered the same.
One last note. In his bestseller 1988 science book, A Brief History of Time, physicist Stephen Hawking draws one beautiful line. the discovery that the universe is expanding was one of the great intellectual revolutions of the 20th century. And indeed, it was.
Religion isn't something that you should follow blindly. If you have questions, you need to do research and find the answers. It is the uncorrupted way to worship God. So I hope that, inshallah, you will find my webpage helpful. So, assalamu alaikum wa rahmatullahi wa barakatuh, and peace be on you.